Discovered atomic nucleus by bombarding gold foil with alpha particles. That was Rutherford. Blank oxides of metals are what? So oxides of metals are basic metals, and then while oxides of nonmetals are acidic nonmetals. Disproportionation reaction. A disproportionation reaction in which one atom is simultaneously oxidized and reduced. So 1 liter of H2O, how many grams is that? That's 1,000. Change in the boiling point when a non-volatile solute is added. You can get that, but the equation change in T is equal to Kb times M times I. M is equal to molality. Then you have the Haber process. The Haber process says that 3H2 plus 1 NH2 is forward and reversible with 2 NH3. Okay, the pH is equal to the pKa at what? At the half equivalence point. Okay, deviations from the ideal gas law here are greater at what? Low temperature and high pressure. Forms precipitates in H2O. Ag, Hg, Pb, BaSO4, CaCO3, SrSO4. Soluble in H2O. Alkali metals, NH4 plus, NO3 minus, HCO3 minus, Cl minus, Br minus, I minus, SO4 2 minus. And then what's the charge of ASO4? ASO4 is a -3 charge. So the graphs here, let's determine which order they are. So right here, this with the y-axis being the concentration of A, and then the time down here for the reaction being the x, it goes with a negative slope, as you can tell. That is a zero order reaction. Then you have right here for B, the ln, so that was right, zero order reaction. Then for B, you have the ln of the concentration of A on your y-axis and your t time x-axis right there. And then you have also continued negative slope, just like the zero order reaction. So that's going to be a first order reaction. You can also write the graph this way, where you have the concentration of A, and it makes this like dip right here. And there's T right there. So that's a first order for both those graphs. Then you have C right here. So 1 over A's concentration. It inverts the graph and you get a positive slope over time T. And so that's going to be a second order graph. Let's name these guys. So that's HCl4, right? So what's that? That's perchloric acid. Then we have HClO3. HClO3, what's that? Chloric acid. Then we have HClO2, that is chlorous acid. Then we have HClO, and that's going to be hypochlorous acid. An alloy, what's an alloy? An alloy is a mix of metals typically used to add strength to the metal. Allotrope, what's an allotrope? When an element exists in 2 or more forms. I think an allotrope could be, to say, element, you could have O2 or O3, for example. Ozone or oxygen gas, right? Okay, diamagnetic versus paramagnetic. Well, obviously, diamagnetic electrons are all paired up. paramagnetic, some electrons are unpaired, spin-wise. Lanthanides. Lanthanides are rare earth metal or earth elements that fill the 4f orbitals. And actinides are what? Elements that fill the 5f orbitals. Solvation process is what? Solvation is a process in which an ion or molecule is surrounded by solvent molecules. Okay. Periodic table trends, decreasing and increasing. So if we take a look at electronegativity, we notice that it increases as you go up and to the right of the periodic table, left to right. Okay. Then we take a look at electron affinity. Electron affinity will increase as you go up, just like electron negativity. And also left to right, it will continue to increase. And then atomic radius, that one's actually going to go towards francium down there. So it increases as you go down and to the left instead. Then we have metallic character. Metallic character will increase as you go to the left and down again towards francium. Ionization energy. Ionization energy will increase as you go up and to the right, just like electronegativity and electron affinity. Maximum number of electrons. The maximum number of electrons is 2n squared equals the max number of electrons. So n will be your rho and the shell number or shell number. Okay, next equation here, internal energy change. The internal energy change is the change in E is equal to Q plus W. Internal energy change is equal to heat plus your work. All right, the kinetic energy depends on what? The temperature. And then the potential energy depends on your phase. So gas phase is going to be the greatest potential energy, and solid would not be, obviously. You decrease in potential energy going to a solid from the gas. Solid, liquid to gas. Okay. Next one, intensive versus extensive properties. Intensive do not depend on sample amount. Extensive do depend on sample amount. The SI unit of pressure is going to be a Pascal. 1 torr would equal 133.322 pascals. The rate and concentration. Rate and concentration are explained by this equation right here. The rate is equal to the rate constant K times the concentration of A times concentration of B and whoever else is involved there. Also, we have the pressure and volume are related by this equation. The P1 and V1 are equal to P2, V2. M1 and V1 are equal to M2 and V2. Comparing gas speed. Okay, this equation is going to be the speed of gas A over speed of gas B. The ratio is equal to the square root of the mass, the molar mass of B divided by the square root of the molar mass of A. The equation for going from Fahrenheit to Celsius, that's easy. Its Fahrenheit is equal to 1.8 times the Celsius plus 32. Okay, energy in relation to temperature. Well, this equation explains it. It's the change in H is equal to MC change in T. So the change in H is going to be in joules, the mass obviously in grams, the specific heat has its own units. Okay, and then R, that's not even in that equation. Okay, so next equation, we need to explain pressure in relation to molar mass and density. So that would be your pressure times your molecular weight, molar mass, is equal to dRT, equal to density times R, which we're dealing with pressure here, so it'd have to be this R right here, the 0.0821 liters times atmospheres over moles times Kelvin times the temperature last. The density is D in that equation. All right. I is equal to Q divided by T. I equals amps, Q equals coulombs, and T is time, seconds. Okay, this next equation is the standard electrode potential. It's E equals E naught minus 0.0591 divided by N log Q. The number of N is equal to the number of electrons given in the half reaction. E naught is a standard electrode potential. Electromotive force is E at a new concentration, and then Q reaction quotient or KQ. Work, pressure, and volume. Let's do that equation first. So work is equal to the negative pressure times the change in volume. Osmotic pressure equation says that this here pi, which is the osmotic pressure, is equal to big M molarity times R, which constant has to be related to pressure since we're talking about osmotic pressure, so it's going to be the 0.0821 value, and then we have times T, the temperature, in Kelvin, of course, and then I, particles. All right, let's go to C. C says the change in G, Faraday's constant, and E naught in relation to one another. So Faraday's constant, they have it down here, is 96.5. I need to check that one actually. Times N, which is the number of electrons transferred, and yeah. Okay. Next equation says, let's do energy and light. So energy equation says that energy is equal to Planck's constant, which is 6.626 times 10 to the negative 34 meters squared times kilograms per second times the frequency. That's the energy. It will be found in joules. The frequency is in hertz. E is equal to hc divided by the wavelength. C, of course, is the speed of light, which is 3 times 10 to the 8th meters per second. And then, hertz are cycles per second, by the way. Wavelength will be measured in nanometers. All right, let's do some organic chemistry here. So Br2, ClCl4, and coal dilute potassium, I think it's permanganate, tests. All right, what happens in those tests? So the tests react with compounds containing double or triple bonds, not aryl compounds. Okay, orange, brown, so Br2 with CCl4 goes to colorless, and then purple, potassium permanganate, turns brown. Okay, and that checks for double bonds or triple bonds, but not in aryl compounds. Okay, then the UV spectroscopy does this: detects conjugation and involves transitions between electron energy levels. Electrons become excited and promoted to higher energy orbits. Conjugation decreases frequency. More bonds equal higher frequency. An example would be that a triple bond between carbons would be greater than a double bond in the UV spectroscopy. Okay? Okay. An anomer. Anomers are an epimer that differs around the anomeric carbon in cyclic sugars. Amphipathic. Amphipathic, a molecule like a protein that has both hydrophilic and hydrophobic parts. Okay, nuclear localization sequence, the NLS.